Hey, welcome everyone to Astronomy Daily Live. How's everybody doing today, tonight, this afternoon, wherever you are on this supposedly spherical planet? I think there's pretty good indication that it probably is. So yeah, I hope everybody's doing well out there. Everything's good here. It's 2 hours UTC, and it's time again to gather the tribe here together and think and talk all things astronomy, space, science, nerdy things like that. So yeah, I hope everybody's doing well. It's currently clearing up at my location, but I think it's going to be a little cold. I think this is probably our last cold night for the next several months here in southeastern Arizona, where, yeah, once it gets into the middle of April, we're pretty much clear of all the cold. And when I say cold, I do put that in quotes because I know very, very well that what's cold here is warm pretty much everywhere else. But yeah, so I think tonight here at my location, so I'm on Mountain Standard Time, so I'm always 7 hours behind UTC, and so my local time is 7:02 p.m. here, and yeah, it's I think we're gonna have one more coldish night. Humidity is going to be a little bit high too. We actually had some rain last night, which is that's pretty unusual. So you know, that's just how it goes. There is no average day. Every day is unique and special in its own right, and yeah, the concept of an average is just that. It's an imaginative concept that really never happens. There's always some kind of a distribution of sorts, and scientists, they work with stats and distributions all the time, and so yeah, you come to realize really quickly that there's no such thing as an average anything at all. Point to an average person. Can't do it, right? The average number of kids in a household is like 2.5. I challenge you to show me half a kid. So it just doesn't happen. so yeah, don't be fooled by stats. Stats are good to sort of give you a feeling about things, but don't lean on them all that much, because they're not going to tell you very much at all. Anyway, so I'm just babbling along here. I always like to do that right at the beginning of each live stream, just to let everybody come on in and settle into our virtual porch, or like a virtual campfire that we're all sitting around. We've got our favorite consumables of choice. So I've got a little bit of coffee left here, a little bit of coffee that's still hot. So cheers. And I've got the hydrogen hydroxide again, the HOH. There's actually, have to look this up. There's probably some DOD in here too. Some deuterium. What would that be? I don't know what you would call that. Anyway, there's probably, you know, some heavy HOH in here too, which is instead of a hydrogen atom, you have a deuterium atom. So I think there's I think there's a measurable amount for sure. So yeah, nice combination of things. Anyway, cheers to that. And I noticed that Bobby has popped onto the panel. Hey, Bobby, what's going on? Can't hear Bobby. He can't hear me. Can't hear you. He's having some technical difficulties there, and he is on it. He is absolutely on it. So Bobby gets business done. When there's a problem, bam, he's right there. He's right there. So yeah, all right. Well, he'll. Oh, I heard something. I heard a pop, but that's about it. I still do not hear that very familiar Bobby voice. So he's pulling plugs. He's trying to switch around, trying to do stuff. Oh, he's gonna pop out. He'll probably pop back in here. So Bobby's one of our regulars here. Really turning out to be a great friend, and yeah, here as often as I am, which you know, crazy people like us are definitely allowed here, for sure. But whether you're new to astronomy, or you know, have been in it for a while, or are a pro, you are extremely welcome here. And this is just a fun, casual get together. I'm not necessarily here to teach anything or to do any kind of science education or science communication. Those kinds of things will happen all by themselves, I think. And I'm also learning. Being a scientist, I want to learn. I have a insatiable curiosity about most things, and if you get me into the right mood or the right mode, I will just absolutely bombard you with questions and speculations and all that. It's great fun. So yeah, while Bobby's trying to figure out his thing, I will definitely say howdy to Tom. Hey there, Tom. Nice to see you. Hey there, Ray. Yes, it has been a while. Hope everything is well out there. Mr. Cow Chicken. Well, I really like that name. But apparently you have been bammed. So let's see. Ray is saying, okay, yeah, you're okay. Southern Illinois. So yeah, the exact same storm that passed by me yesterday and last night is going to be slamming you. So yeah, the same old thing. Hey, Bobby, I hear something.
Yeah, I don't know what is happening here.
I don't either, but
for some reason, my USB hub, my USB port on the left side is transgressing for some reason. Sometimes
yeah.
server goes bad.
Your video is extremely choppy, and your audio is right on the edge of being just non-functional. So
Yeah. Yeah.
you.
I,
Oh yeah, he's just choppy Bobby tonight. These machines,
yeah. I
we
prefer the system too, so it's going to be a little while. Let
okay.
me do something.
Sounds good. You do what you got to do, man. Bobby
Yeah,
will be
it's
back.
okay now. I'm
Well,
still here.
let's give it a try. Whatever you want to do.
Okay. Test 1 2. Test 1 2.
Yeah, sounds all right. I think your video is still extremely choppy, but
Yeah, I might have to run into cleaners and stuff. I don't have a cleaner yet.
oh, I gotcha. I gotcha. Okay. Well, hang in there. That's we're in this interesting time where this technology, we sort of have it sort of working, kind of, sort of, and when it works, right? When it works, it's like wow, it's just incredible. And when it doesn't work, I don't know about you, but I feel as though I've been just thrown back into the dark ages. So yeah, and we're in that sort of really really early phase where things are kind of sort of working, and most of the time they sort of do, but once in a while you just get this big fail, and it's like, ay, oy vey. So all right, well, good. You hang in there, you do what you got to do,
Should be
and
stable by now.
okay, yeah, that you sound much better now. So
Yeah,
cheer.
sometimes you gotta let the computer do its job before it really stabilizes.
Just let it go. Just let it do its thing, whatever it's gonna do. So
Yeah.
okay,
Uh,
so Ray is saying that there's a big Windows update next month. Okay, all right. Big as in uh, uh, big like a lot of file updates, or big in terms of like major changes. Um, big is one of those adjectives that it's hard to interpret. So all right, well, cheers to big Windows updates, whatever that may be. So I continue to be absolutely fascinated by this eclipsing binary star HW Virginis. It's turning out to be a really really amazing system. It's the models sort of indicate that it's some kind of perhaps a contact binary system where one component, the primary, or the A component, is what's called a subdwarf, which is the core of a red giant star. So the atmosphere of the star has sort of been blown off and has evaporated. I'm not exactly sure what's happened to that exactly. So you have this core, and it's being orbited by an M dwarf star, and the separation between those two stars is about 1 solar radius, or about 15 arc minutes as seen from Earth. So past couple days, I've been thinking about what that would look like, and yeah, we'd be able to see that from here. We'd be actually able to see those two components, and they are orbiting one another every 2.8 hours. So um, One of the interesting things about this system is that we're pretty sure that there are at least two planets or two bodies of some sort that are going around the entire binary system. Don't necessarily know if they're planets or not, or if they're, you know, something else. But something is perturbing that binary orbit just enough that we can actually see, the parameters of the orbit change, the inclination and the period and all that change. So, okay, so new version update, 6 gigabytes. Holy moly! Wow. If you multiply that by the number of computers on the planet, wow, that is like that's a lot of data. So yeah. Okay. Oh, a lot of streamers got shut down. Wow. Yeah. Like I said, we're this whole computer technology thing is still being conceived, right? We're in the process of conception. We're quite a ways away from an actual birth, if you want to use that metaphor. So, all this stuff is still being conceived. So, the fact that things are breaking and falling apart and failing, and then they work really well and then they don't, that's a clear indication that yeah, we're still in the process of just conceiving this whole thing. It's going to take us a while, I think, to work all this out. Maybe if we get, like the AIs running, they can sort of take over, the development of technology, and we can just sit back and enjoy the ride, right? And not have to really do that anymore, because I don't know if we're really any good at that. So, we keep messing things up. So yeah, cheers. But anyway, so
I got bottled waters for days.
Bottled water for days. Excellent.
Yeah.
Excellent. You are well supplied. Well supplied. I remember when I was a kid, the concept of going to the store and buying water was one of the most ridiculous things that we had ever heard of. Like, why would you go and who would want, why would you have to do that? And now it's just commonplace, right? So, I'm predicting, and I don't know how, I don't know when, I don't know why, but I'm thinking, like air, right? Air is going to be, you're going to be able to buy bottled air, and that's what you'll breathe, to get some good air. Who knows? So yeah, I'm showing my age a little bit, but that's okay. I just I still think the concept of bottled water is just, I don't know. It's just really, really amazing. But you see stacks and stacks and stacks of it at the stores, right? Just gallons and gallons and gallons of it. So I just think it's amazing. So I am definitely blessed once again, to be able to pull this right out of the ground, and it's just here. So there's no treatment, no nothing at all. It's this is probably full of, I mean, I know, that it's full of minerals, but I'm sure it's full of bacteria and viruses and, just all kinds of nasty, nasty things. But, a lot of those things we actually need to be alive and to be healthy. So, to sterilize everything, that's not really a good idea. But yeah, city water is treated. They have to make sure that it's safe, understandably. So yeah, I totally understand why we now want bottled water because it's probably better for you than the city water is. So cheers! But this is right out of the ground. So awesome. Anyway, so yeah, I'm still completely blown away by this eclipsing binary system, HW Virginis. I actually took a look at the data that I collected on what was my evening of April 7th, and the light curve is absolutely gorgeous. Why don't I get into this a little bit and share my screen and do some show and tell here before we get more into things.
Yeah, everybody's here in the chat is talking about the rain. I'm gonna get some really bad freaking weather.
Yeah. Like I was saying, you're gonna get the storm that I got yesterday. So it's rolling through the United States, and it's a doozy. It's a doozy.
And what's also going to be weird is that my weather radio is going to wail like crazy. Let's actually give it a.
Seas 2 to 4 feet. Now for the official national weather.
Good to have a weather alert radio.
Oh, absolutely. Yes. All right. Well, let me do some show and tell on HW Virginis. I will show you some pictures, and then I'll show you that what I consider to just be an absolutely beautiful light curve. So I'm going to share my screen here, and so here is an individual image. Maybe I'll try to do, yeah, okay. So here is a single 3-second exposure. And this star right here is actually the target star. That is HW Virginis right there. And then I've got a couple other stars in the field of view that I can use as references. So when you're looking at variable stars, it's always nice to have a reference star right in the same field of view, because it's looking through basically the same atmosphere, and so the brightness of the sky is going to be exactly the same here as it is here, more or less. So you can actually do what's called differential photometry, where I just measure the brightness of this star and I compare it to the brightness of that one and or that one, and then I can do this for each image I take. And in this particular data set, I've got to play with it a little bit more, but I've got about 360 images that spanned about an hour's worth of time, maybe a little bit less. We'll look at that. But this is a single 3-second image. So one of the things I can do is I can take each of those 360 or so pictures, and I can stack them to to effectively create a long exposure. So I'm going to grab my handy dandy fully functional calculator here, and I'm going to take 360 images and multiply that by 3 seconds. So fully stacked, we're talking about this exposure time is 1,080 seconds. So what, about 18 minutes of total exposure time. Now, like I said, this this entire observation went on for about, I don't know, maybe about 50 minutes or so. And so, you know, the reason why I only have an 18-minute exposure over the course of 50 minutes is because each image has to be downloaded from the camera to the computer, right? And that takes about 5 seconds per picture. So, you know, there's a little bit of overhead there. So, but if I stack all of these one on top of one another, what I get is that. And so a lot of this is sort of noisy pixels that are hot and everything else, but you can definitely see here's HW Virginis again. Here are the two comparison stars, but look at all these other stars that have sort of popped out that you can't really see in a single image, but when you do a long exposure, you can definitely see all of these. Now, like I said, things like this and this and this and maybe these here, those are just bad pixels. But sort of the fuzzier things, the blobby things here, like these two, and this one over here, and these two guys, those are faint stars. I actually went to Gaia and I looked up the magnitudes of these two stars. And this star, the bottom one, if you look in the upper right here, there's sort of a zoomed in view. This bottom one here is about magnitude 15.7, and I'm sorry, 15.4, and this top one is about magnitude 15.7 or so. So that's pretty good. You know, getting some pretty faint objects. HW Virginis itself is about magnitude 10.5. These two stars, you know, I don't know if I've looked to see how bright those guys are, but my guess is that they're sitting maybe around 11th or 12th, something like that. So yeah, and so this little tool, one of the things I can do with it is actually blink those two images. So we have that one and that one, and I'm actually gonna, let me make this small again because otherwise it's gonna look a little weird when I blink this. Let me I'm gonna
It's
put
going to be
this over
better if you
here.
hide the wormhole with a chat window.
Yeah,
Like
yeah,
with the
that's a good idea.
DS9.
Yeah, that's
Yeah,
a good
there you
idea.
go.
Good idea. What? Let me try that again.
Yoo-hoo!
Let me try that again. Sorry. I grabbed the wrong thing. Okay, so now let's just blink these back and forth, and you can sort of see how, you notice how there's, you know, the background noise is a little bit smoother, and of course the fainter stars, which here, I mean, like this one, right? That's pretty obvious there with the long exposure. But if you look here, ooh, it's just barely there in a single image. So, but stacked, it just pops right out, no problem at all. A good signal on that too. Really nice. Really nice. So so yeah. So that's actually one of the things I can do. But since this is a variable star, right? This star or this system, when it goes into the eclipse, actually dims by almost a magnitude. And so what I can do is I can compare the brightness of the target star to one of the reference stars, and with the case of the plot I'm going to show you, it's this brightness versus this reference star here. Now, I definitely want to use this reference as well, and that'll give me some confidence that my measurements are good. But if I do that over the entire span of this observation, which, like I said, I think ran probably about 50 minutes or so. I'm not exactly sure. But what you get is a light curve that looks like that. Let me back that up a little bit. There we go. So I think that is just absolutely gorgeous. Looks really good. This axis here is the Julian date, and it turns out, and these there are certain things that I've heard of, but I've never paid that much attention to because I've never really had to. But it turns out that there are different kinds of Julian dates, and there are three that are sort of relevant to this kind of observing. There is the geocentric Julian date, which is the Julian date on Earth. But there's also two others. There's the barycentric Julian date and the heliocentric Julian date. And when it comes to timings of events, it's really important to know which one of these times you're talking about. What I noticed is that my timings on when this bottoming out here took place didn't match the timings that were predicted.
Welcome Deep Sky Dude. This Deep Sky Dude in the chat.
Hey there, Deep Sky Dude. Nice to have you here. So the timings of these that I measured didn't match the predicted timings. I was off by several minutes. Well, it turns out that you have to take into account light travel time between the Earth and the Sun, because the timings that are published are usually the heliocentric Julian dates, and that can be different than the geocentric Julian dates by 8 minutes or more, right? because it takes light 8 minutes to go from the Earth to the sun, and you have to take that into account. So yeah, learn something new every day. That is what I learned today. But anyway, this is an absolutely fabulous looking curve, and one of the things that I notice about this curve is that this side, as it actually dropped in brightness, this shape here doesn't exactly match that shape. See how this is sort of a very, very steep drop off here? This one's a little bit more gradual, so it's not entirely symmetric. It's really, really, really close. But yeah, I'm extremely anxious to start creating some models for this system, and generating some light curves, to see if I can match those things up. So yeah, it just that was really, really nice to see that kind of a curve. It's really, really, really great. So I'm pretty happy, with how my system is performing. The data is kind of noisy, but again, it's definitely not bad. Definitely not bad. So this is definitely usable data. So yeah, I'm sort of the next phase here is to get into the models, and see if I can generate a light curve based on the models that closely matches this light curve. So yeah, that's sort of the next phase, and I'm going to excuse you.
Yeah.
So I'm going to be using a Python package that's called Phoebe, Pheobe, and it's
Speaking of Python, the way that I had to do pip to get my to get an application working, I had to tell it to do it in Python 3 instead of Python 2.
Right. Yeah, it sort of depends on the application, and yeah, I learned exactly the same thing, Bobby. That
Yeah. And don't forget, I think Python 2, which is in Python 2.7, is heading out the door soon.
I believe you're right. Yeah, I think everything's going to be going to Python 3 soon. Right now, we're sort of in a transitional phase where, there are some applications that, you've got to run under 2.7, and some applications you run under 3. So yeah, it's sort of a pain at the moment, but as long as we understand all of that, no problem at all. So but yeah,
probably when Ubuntu 20.04 releases, which is going to be the latest LTS. They usually do an LTS every 2 years. And maybe that will have Python 3 as default.
Yeah. Cool. Well, I know things like GIMP. I think they're still leaning on 2.7. So even they have to upgrade. So yeah, but yeah. So I'm
and I'd like to welcome Kira H.
Hey there, Kira H. Nice to see you there. So yeah, we are doing astronomy here. I'm actually just looking at a light curve from a eclipsing binary star called HW Virginis. This is data that I collected about a week ago or so. And then this is a really, really fascinating binary system that yeah, I've just been sort of obsessing over, and I think I'm going to continue to obsess over. And yeah, the data looks really, really good, really, really good. The images are nice. Here's a single exposure, 3 seconds long, and then here's a stack of about 360 of those, and you can see many of the fainter stars pop out in the background. So yeah, and this is actually HW Virginis right there. And I've got these 2 stars in here to use as references. Supposedly, hopefully, right, the brightnesses of these stars don't change while this one does. And that's actually what we're seeing here, is that the brightness of that star.
I hear your kitty.
Yeah, I think somebody wants in. So I might have to go and do the human duty here. I'm just gonna blink those 2 and go let this guy in, so he can he probably wants to look at the light curve too. So I don't blame him. So I'll be right back. Just hold on one sec. Okay, come on. Here we go. Oh, come on. Well, you got to get out of the way, though. Here we go. Okay. All right. Yeah. He immediately jumped onto the desk, looked at the light curve, and said, "Yes, I approve." So we have the kitty approval here. So anyway, so yeah, this is really, really great. Looks really, really good. I am really, really pleased with this. So far, so good. So
yeah,
awesome.
I just got done listening to This Is a Music Show. If you was more into digital, if you was more into digital stuff, This Is a Music Show is a good show for you, especially like shortwave radiogram, the ABC when you did digital. But yeah.
Cool.
And yeah, and I think she also heard a cat as well.
Yep,
and
I
she
see
has
that.
2 cats.
Cool. Yeah.
Good for you, Kira. I just got myself a little dog right here that was he's a little bit up, but I don't have my stuff programmed to use my phone as a camera, but yeah.
Yeah. And Kira, we ran a rescue here for probably about 10 years or so, and finally had to give it up. But we are dealing with all the residuals. So we have quite a crew here, and they keep us going, and we are definitely servants. That is pretty much it. They don't have thumbs, so they have a hard time opening doors. So that's our primary job, is to make sure that doors get opened.
Yeah, I used to have an outdoor kitty as well. We raised as a kitten. I think the mother, for some reason, abandoned the cat. And we just out of consent of blue found a kitty. And we just raised them until I think what happened is I think he went like to the highway, because we got like a little state highway this way.
Yeah.
And I think he got ran over and killed him.
Yeah. Well,
But he's been through some battle wounds too. I think in one of his legs, the bones exposed.
Oh wow, yeah. Well, that is the price of freedom, right? If you're going to be free, like that, there's a lot of risk, and my attitude is enjoy them and love them while they're here, uh, and that's all you can do, right? Protect them if you can, but they thoroughly enjoy freedom, and for the most part, most animals, they live in the moment, and we could learn a lot from that, right? They don't necessarily worry about the future, and they don't have any kind of real hang-ups about the past. Not really. They live in the moment, and boy, we could definitely learn a lot
We
from
also
that.
raised a cat when I was in my older house in Patterson,
Mm-hmm.
and we raised him as a kitten. And so I think something happened to the mother. Then brought probably a snake that probably bit the mother, and we raised him as a kitten. But he pretty much didn't like the way his wife was doing. So two things could have happened. I think the same snake that bit the mother bit him, or he committed suicide.
Could be. Yep, could be. It's life is rough, so you just have to you just got to be as careful as you can, and when your number is called, you go. That's it. So, all right. Well, the other day, Tom posted a paper about something about
Oh,
asteroid.
did you see that? Do you see that? Well, did you see that rocket launch? Yes, that earlier today.
I did. I did. Did you watch that one?
Oh yeah, I had a notification for it, and I just say, well, I got nothing to do. I'll just go ahead and watch it.
Yeah, yeah. I did too, and yeah, it was just this.
And where is
That was
this
a
Nordred Goldweg or I don't know how you do the name is from.
Northrop Grumman.
Yeah.
Yeah, it's just a company. They're some kind of a aerospace company, and they've been around for decades, long time, and they have a contract with NASA to do these resupply cargo missions to the space station, and that's exactly what this launch was. Was to just send up some supplies, I think some new
Yeah.
experiments, those
Yeah.
kinds of things.
Now,
So yeah,
how
I
long
think.
that you can actually be in space now without any kind of modifications with your DNA and stuff?
Well, that's a good question. They're actually uh, uh, they are trying to study that, and I don't think that there's anything really conclusive yet. They're one of the astronauts that was up there for I want to say over a.
I think
Go ahead.
like 2 years, 2.5 or something is the longest.
Yeah, I think the longest that anybody has been up there so far hasn't quite been that long. Maybe 400 days, something like
Okay.
that. Um, but one of the experiments that has been done, one of the astronauts, Scott Kelly, he was there for these 400 or
And
so
speaking of the
days.
ISS and all that, did you not know the one that brought amateur radio in space died? I think about a few days ago.
Yes, I heard about that too. I think actually Tom posted something about that over in my Discord server as well. And there's a link actually to the Discord server down in the description. And I'll bet you
I'm going to put the command up on it.
Cool. Thank you, Bob.
Just want to make sure. Here we go.
Yeah. So anyway, Scott Kelly flew in the ISS for, I think, 400 and some days.
So Kira, out of my curiosity, if you just like discuss about microgravity effects, I think you, well, okay, I don't see it. Oh, okay, she never did any videos, but okay, so
yeah, and
she doesn't have anything, but she did say that she discussed about living in space can modify your DNA or something, or I don't know what WSH is.
Weekly Space Hangout. If you're not watching the Weekly Space Hangout,
oh Lord,
you got to watch those things, Bobby. Yeah. So
okay, now I'm getting it. I'm getting it now.
There you go.
Oh my gosh.
Very, very good. Anyway,
okay. Sorry.
Yeah, no worries. Scott Kelly has a twin, and the twin stayed here on Earth, and Scott Kelly, was up in space, for 400 and some days, and so they have sort of a side-by-side comparison, and there were some interesting findings there. So I don't think that there's anything conclusive yet, which is puzzling to me, because we humans have been out in space since the late 50s, and that's like 60 years ago, and we still don't have anything conclusive about what space does to us. I don't know. That seems, that to me is sort of a red flag. I'm sort of like, maybe we know more than what is actually being talked about. It's probably pretty rough. It's probably really, really rough. Yeah. Morgan was talking about that on actually today's Weekly Space Hangout, and they're actually going to have a guest on May 22nd, I think is the date they said, and that guest is at least one of the people that is involved in that work. So that'll be really, really interesting to see, because yeah, I mean, we don't really know what happens to us when we're up there for long periods of time. So we got to find those kinds of things out.
Speaking of Fraser Crane, I wonder what's happening, because they used to do that star party with Skyrius on Twitch, and something happened and it never came around. But but that was front page.
Yeah, I think my guess is that two things happened. The first thing is that after they did it a few times, I think they sort of burned out. And also, you sort of have to, after you've looked at the same thing over and over and over again, you sort of have to wait for the sky to change. So we're moving out of the winter sky. We're moving into the summer sky now. So I'm hoping and sort of anticipating that that's going to come back. But yeah, I think that might have just been sort of a burnout thing. that's a substantial amount of effort.
I mean, the last time they did that star party, I think there were lots and lots of great people that were more into space, like Pamela Gay that came on, and I forgot who else came on.
Oh yeah, yeah. Okay, Ray.
Yeah,
Take
Pamela
care,
Gay,
everybody.
the Star Strider.
Yeah, yeah, yeah. Yep. Take care,
I
Ray.
wonder, you want to know something? I haven't been on Twitch lately. The only time I've been on Twitch lately is Check Me Out, and she does
Okay.
that singing modes and stuff. And have a good night, Ray. And
Yeah.
I need to reprogram my Twitch account on my Roku and see if Star Strider's on.
Okay. Yeah. Well, I know that CosmoQuest X is doing the daily space, which I think is a great name. So that's every weekday. Um,
Yeah.
either
I
either.
miss Coco the Router.
Okay, yeah, I don't know about that one. Yeah, I don't get onto Twitch all that much. I'm usually working, many of those things you have to sit and sort of watch, and I'm trying to work on things. I can't be watching stuff. Yeah, that's just how that goes.
Yeah.
So. All right, well, cool. I think, I was going to touch on a what looks like a really interesting article that Tom posted the other day about these stellar occultations of asteroids. But I think I want to hold off and do that another day because I'm looking at the time and I'm noticing that we're coming up to the hour, so I don't want to get too much into things. But one of the really cool things that you can do with these occultation events is actually distinguish and determine the shapes of the occulting body, the shape of these asteroids, and there has never really been a way to confirm these observations. Now look at this. I've got a kitty back here who is manipulating the camera. Now look, you cannot sit on that wire. You got to get off the wire, dude. There we go. All right.
Oh my gosh.
This is the one. This is the one that's messing with things. Look at you.
That's it.
Hello. Yeah, you're in big trouble. You're in serious trouble.
Right under the big machine.
Yeah. They're determining the shapes of these asteroids has been a thing that's been going on for years and years and years and years and years. But one of the things that you can't really easily do is confirm that what you're seeing is actually the shape of the asteroid. You can make a good guess, and it's like, okay, well, maybe that's the shape, maybe not. But Ultima Thule, which is the trans-Neptunian object that New Horizons flew by a few months ago now, we actually have, very good pictures of that thing. We know its shape really well, And one of the ways that, prior to the encounter, that they were actually able to sort of get an idea of the size and shape of this thing was actually observing occultations. And so I think I'm just going to leave you with this. I will show you what that looks like. So I'm going to share my screen once again, and we'll go through this here a little bit. Share the screen. I'm going to do that. I'm going to hide that. I'm going to go over here. So this is just the Wikipedia entry for Ultima Thule, but I want to direct you to this diagram here, or this image here. So these lines correspond to locations on the Earth that attempted to observe this occultation. And what you can see here is that there are these bright lines, and then they turn like dark, and then bright again. So this is when the star is sort of on. This is when the star is being blocked, and then this is when the star comes back on again. You can sort of imagine that moving along these lines is time. But what you can see is that this object actually casts a shadow onto Earth that we can actually see. And so what they saw, right, they spread these over a little bit of an area here. What they saw was, that it was, the background star was bright, and then, for this amount of time, it dimmed out and then brightened again, right? And it did it here and here and here and here. And they kind of tried to come up with some kind of a model, to fit those. And amazingly enough, look how close that comes to the actual shape. Now, when I saw this, that just blew me away. That we could be that accurate in terms of a shape. We nailed it. From the ground, we could get the shape and size of this asteroid that is, 40 astronomical units away. I mean, way out there. But as it passes right in front of this star, it casts a shadow, and we can actually see that. And so there it is. It's totally amazing. This blue area, of course, is the shape of the asteroid, and you can see how closely it matches, the model, and also, the observations. Matches extremely well. Just absolutely amazing. So here's one of the occultation events. You can see that star right in the middle is bright, and then it goes faint, and then it brightens up again. So that is the asteroid actually passing in front of that star. Now, we can't see the asteroid. It's too small. It's too faint, right? We can't see it. But it will block the light from the star for a certain amount of time. And depending on where you're located on that path, you'll see different times in terms of how long the star is dimmed. And so that's how this model is made. So this is just one of the locations. I don't know which one, but yeah, so pretty amazing. I love asteroid occultations. I think they're absolutely fantastic. And if you haven't seen one, you definitely should. It's definitely a rush, to actually see a star just vanish for seconds, maybe minutes, right? I mean, it sort of depends on the motion of the asteroid. Um, but so yeah, these kinds of things. But I'm just absolutely amazed how well the observations match the actual ground truth, right? Because we've sent a spacecraft there, so we know more or less exactly what the shape is, and it matches. It's absolutely fabulous. So that gives me, and I'm sure it gives all the asteroid occultation folks, a lot of confidence that their modeling is probably pretty accurate in terms of determining shapes and sizes and velocities and all of that. So pretty amazing. Three cheers to all that. I think that's just absolutely fabulous. So yeah, they actually used 24 different telescopes to capture this event. So yeah, it was a pretty big deal, and but they nailed it. They nailed it absolutely. Okay, well, I think I am looking at the time, and I think it is definitely uh, a good idea to probably get on out of here for today. Um, Now, just as a reminder, tomorrow the live stream is canceled. So that is for the 19th of April. Yeah, I've just got a few things going on in the afternoon here, and I probably will be back in time, or I would, but the number one thing that I hate more than anything else is having to hurry. So if there's any chance that I have to hurry or rush, I'm just not into those kinds of things. So yeah, I'm just going to cancel tomorrow's live stream. We'll definitely be back on the 20th for sure. So come on back if you can and want to. I am usually here every single day, 2 hours UTC, talking astronomy, space, science, nerdy things, radio things. We're just a bunch of friends here chit-chatting about whatever. So nothing is really totally off the table. I definitely like to talk astronomy and space and science and all that, but tangents are definitely allowed, and so bring them on. So okay, everybody. Well, for now, I think I'm going to get out of here. So peace, cheers, and all that. I will see you in well, I guess about 48-ish hours or so. Something like that. A couple of spins of this little round planet here, and so just hold on to your hats. Don't get too wet. It sounds like there's some storms blowing through at least the United States. So get your umbrellas out, and it's a pretty fast moving storm, I think. So hopefully it won't last too long. I'm also going to be clear here tomorrow, so probably out. I'll probably be out observing. It's pretty much full moon, so I'm limited in terms of what I can do in terms of faint stuff, but I can definitely get like eclipsing binary stars. So I think I'll probably be doing that again. All right, everybody. I think I'm going to get out of here for now. So thanks so much again for coming in. You can come on in anytime you want, every day, every week, every month. You are welcome here. So, all All right, buddy, I'm out. Take care. Peace, cheers, and all that. And I will see you in a couple spins. All right. Take care, everybody. Bye.
Bye.